In this presentation, we are going to explore the Open Systems Interconnection, or OSI model. The OSI model is a conceptual framework used to understand how data travels across a network. Let's dive into understanding the 7 layers of the OSI reference model. So, what exactly is the OSI model? OSI stands for Open Systems Interconnection. It is a conceptual framework that is used to understand network interactions. It was developed by the International Organization for Standardization, or ISO, in 1984. It divides network communication into 7 distinct layers, each serving a specific function. This model provides a standard for different communication systems to work together. The OSI model serves several key purposes. Its primary goals include standardizing network communication protocols, breaking down complex network interactions into manageable layers, enabling interoperability between different vendors' network technologies, and simplifying network troubleshooting. Some of the key benefits of the OSI model are that it provides a common language for network professionals. It also isolates network functions for easier development. It facilitates modular engineering, and it enables changes to one layer without affecting other layers. All these benefits are the reasons why this model is so popular. The OSI model can be divided into 2 main groups of layers: host layers, also known as the upper layers, and media layers, also known as the lower layers. The host layers, which include layers 7 through 5, focus on application-specific functions. These layers consist of the application layer, the presentation layer, and the session layer. The media layers, which include layers 4 through 1, handle data transport functions. These layers consist of the transport layer, the network layer, the data link layer, and the physical layer. Now let's take a closer look at some of the individual layers, starting with the application layer, also known as layer 7. The application layer provides network services directly to end users and applications. It is the layer closest to the user, handling user authentication, data access, and resource sharing. Some of the protocols and services associated with the application layer include HTTP/HTTPS, File Transfer Protocol or FTP, Simple Mail Transfer Protocol or SMTP, Domain Name System or DNS, Telnet, and Secure Shell or SSH. Next is the presentation layer, also known as layer 6. The presentation layer is responsible for data translation, encryption, and compression. It ensures that data from the application layer can be understood by the receiving system. Some of the functions and standards associated with the presentation layer include data encryption, character encoding like JPEG, GIF, PNG, MIDI, MPEG, and transport layer security/secure sockets layer TLS/SSL. Let's continue our journey through the OSI model with a look at the session layer and the transport layer. The session layer, also known as layer 5, establishes, manages, and terminates connections between applications. It handles session setup, coordination, and termination between end-user applications. Key functions of the session layer include session establishment, session management, dialogue control, and synchronization. Some of the protocols associated with this layer include NetBIOS, Remote Procedure Call or RPC, and Structured Query Language or SQL. The transport layer, also known as layer 4, provides end-to-end communication control, ensuring complete data transfer. It handles segmentation, flow control, and error correction. Key functions of the transport layer include segmentation, flow control, error recovery, and managing connection-oriented and connectionless communication. Some of the protocols associated with the transport layer include Transmission Control Protocol or TCP, User Datagram Protocol or UDP, and Stream Control Transmission Protocol or SCTP. Moving further down the OSI model, let's explore the network layer and the data link layer. The network layer, also known as layer 3, provides routing and logical addressing for data packets. It determines the best path for data to travel across networks and handles traffic control. Key functions of the network layer include logical addressing, routing, path determination, and traffic control. Some of the protocols and devices associated with the network layer include Internet Protocol or IP, Internet Control Message Protocol or ICMP, Open Shortest Path First or OSPF, and routers. The data link layer, also known as Layer 2, provides node-to-node data transfer and handles physical addressing. It detects and possibly corrects errors from the physical layer. Key functions of the data link layer include physical addressing, error detection, frame synchronization, and flow control. Some of the protocols and devices associated with the data link layer include Ethernet, Point-to-Point Protocol or PPP, Media Access Control or MAC, and switches. Finally, let's examine the physical layer, also known as Layer 1. The physical layer transmits raw bit streams over the physical medium. It defines the electrical, mechanical, and functional specifications for activating and maintaining the physical link. Key functions of the physical layer include bit transmission, defining the physical topology, determining the transmission mode, and line coding. Some of the standards and devices associated with the physical layer include Recommended Standard 232 or RS-232, Universal Serial Bus or USB, hubs, and repeaters. There are many different types of physical media including twisted pair cable, wireless connections, fiber optic cable, and coaxial cable. As data travels down the OSI layers, each layer adds its own header, and sometimes trailer information. This process is called encapsulation. The data, which comes from layers 7 to 5, is referred to as data. At layer 4 it is called segment or datagram. At layer 3 it is called packet. At layer 2 it is called frame. And at layer 1 it is called bits. When data is received, it goes through de-encapsulation as it moves up the layers. In summary, the OSI model provides a conceptual framework for understanding network communications. Each layer has specific functions and protocols that operate within it. Data encapsulation occurs as information moves down the layers, and understanding the OSI model helps with network troubleshooting. Remember the layers of the OSI model from top to bottom using the mnemonic. All people seem to need data processing to help remember application, presentation, session, transport, network, data link, and physical layers. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.